Okay, so here's a driver program. I happen to have put a hockey player in here, which is our big hockey player that has all of the equals compared to comparators and stuff in it. And so if I do something like this, let's make a hockey player. So there's one hockey player. If I make another one, and we'll call this one Freddie. And then I do something like this. If Fred double equals Freddie, and we're going to do a few of these, so I'm just going to number them so I know which is which. So going to print that out or not? Good exam question, right? What does it print? Nothing or same one? Votes for same one? Votes for nothing? A few don't knows. Let's just run it and see. Didn't print anything. Because, let's go have a look with the debugger for a second here. Put the debugger on that line, and we'll go take a look at what the debugger has to say. Notice those ID numbers on the side of the debugger? Those are essentially, you can think of them as social insurance numbers or whatever. They're unique to the object. They're sort of like memory addresses if you're an assembly language person. So in this case, the debugger is making them up for you to show you that they're unique. So every new that gets called, it basically increases that number. So in this case, those ID numbers are different, and what's being compared here is really the 16 against the Freddie, which is the ID number 20. And so the answer is they're not the same because they don't have the same ID numbers. Okay, so that's comparing really their memory addresses against each other to say whether or not they're identical. So double equals means identical. What if we do this? And we change this to, oops. Dot equals instead. Assuming I can get it spelled right. And then call this same too. What's it going to print out now? Is it going to print out same too or not? Because so that's look like, but the only way you know for sure if that's true is to do what? You have to make sure that hockey player actually has an equals method. So it has to be overriding the existing one. And if it doesn't override the existing one, it's not going to match. So this is saying they're similar by first name, last name. Okay? So the expectation is that it will print out same too. And just for fun, let's go into hockey player and we'll put the breakpoint in the equals. And we'll see whether or not it gets called. So there's the breakpoint and the equals. We'll run with the debugger again. There's the equals being called, and it's being called from main there where we're calling it directly. Okay, so in this case, main is making use of the dot equals we wrote, and so it's going to say that they match because their first names and last names are the same. Okay, so the result of that is true. Well, the sort of common mistake is to do something like this. I'll go back and I'll find my equals. And I'm just going to take off at override and change this just for fun the easy way to hockey player. Are they going to match or not match? Let's just see whether or not dot equals gets called. And it does in that case. Interesting. Let's just do this. Let's just go back into the driver and let's do list hockey player players equals new array list of only hockey players. So I've made my list. I'm going to do players.add both Fred and players.add Freddie. Make sure I do the correct import statements. And then I'm going to say position equals index of and that should be players. And I'll just print the position. Okay, so oops, that should be Fred Flint. Just going to make it, actually what I'm going to do just to show you that they're the same is I'm going to take that exact line and I'm going to plug it into there just to say it's exact. So I've got this list. The list has Fred and Freddie, who are both look similar. Okay, and I call index of. What position is index of going to locate? So if it does the expected thing, I'm going to find one. When I find the first one, I'm done. It should find the 0 position because that's a match. Correct? Okay, we want to make sure that that's what the expectation is, right? Seems reasonable. Hockey player has an equals. Index of uses equals. Equals is going to try to match this new one against the existing one on the list. There's actually 2 of the same thing on the list, so it should find the first one on the list. And that means that the first one on the list, the position it should print out is the 0 position. Let's just run it and see. Minus 1 means didn't find it.
Because it doesn't, or equals does not work that way.
So let me just, the reason this one worked, let me just do it this way. Object thing is Fred and if thing dot equals Freddy. Is it going to print out same two or not?
Yes, because you still have that second line. Go back to
Is it going to?
Go back to hockey player agenda. Right now, because I think you still have that second line that says hockey player thing.
I'm interested in whether or not it's going to print out same two. Hockey players equals.
Still has hockey player other equals hockey player thing. So depending on whether or not like being given an object that looks like a hockey player in the first place.
Going to print out same two?
I expect you will either crash.
Yes or no? It's a simple question. Either it prints it out or it doesn't.
I expect it will either it will print out same two or it will crash.
Votes for printing out same two like it did before? We already know it printed it out when it said hockey player there. We'll do it this way. I'll change this back to hockey player.
That would work.
Print out same two or not? That's just the same as before. I just put it in another variable and it prints out same two. Okay, so I'll change this to, I don't know what it is. It could be any old thing. Match or no match?
Depends on the exact mechanics of language. I want to specify student crashing being given an invalid.
Why did that happen? Because when I use hockey player there, then hockey players equals gives you exactly hockey players equals. When you use object there, it loses its identity, so there is no hockey player, there's just any old thing. Since it doesn't know what it is, what it does is it calls the object's version of equals. There is no thing that matches object version of equals, so it doesn't print it out. Got it?
Yeah.
Let's go back to index of. What does that tell you about index of in terms of the equals it's using?
It's using the generic object equals.
Can't know what thing it's been given, doesn't really care, so the only thing it uses is it defines things as being object in its code that does the searching, so therefore it has to use objects equals in order to do the comparison. And so this one isn't useful for doing objects equals because it says hockey player. So the general one that you have to write is the one that says object here. And if you write the object version of equals with @override, then you're doing the existing one all of the time. And now all of a sudden, when we run the thing, now you get the expected result. Oh, it knows that same two is the same, and the index of works properly. Okay, so the bottom line of this, this whole discussion, is that double equals is identical. Anything that says dot equals is close enough match to think that they're the same thing. But when you write your equals method, you have to use that one because that's the one that's everybody is expecting to use in the general case, because that's the most general thing that you can override for equals. So the hockey player, the specific one, doesn't do you any good there, because in general, when people are playing with these things, they don't care what they are, they just want to call similar to. Questions about that?
I have a question about index and equals. Equals, you can use it when there's no list.
You can use equals anytime you want, but most of the time you don't. You just write it so that index of can use it because it's normally going through a list of things trying to find a match.
But now, index of, you will have to have a list to be able to use it.
Because that's where that thing comes from. The variable on the front of index of is specifically a list variable.
Yeah, I'm asking this because I see on the thing that we did yesterday, we have an equal method, but we don't have an index. Oh.
You can always write the matching thing regardless of whether or not anybody uses it. You can write any function you want just because you think people might need it. They can use it or not. You can write a getter in a class, and if nobody uses it, oh well. It's just that index, it's just that equals and compare to are more likely to be used because people most often want to search for things or sort things. So when you write a class, you write it just in case somebody wants to use it, just like you write a getter in case somebody wants to find out what value something has in the class.
So in the case of yesterday, we wrote the equals just in case, or just to be able to actually
We didn't use it for anything.
we didn't use it.
So you just write it as a matter of course. Just like we write extra constructors whether or not people actually use them. Okay? So, now that you're all clear on that, I'm going to confuse you some more. Let's go to, instead of using hockey player, let's go to using some strings. Steal at my print statement so you don't have to see me type again. Oh, let's do this case first. Oh, no, that one's fine. Are they the same or not? Is it going to print same 3 or not? Because those are asking the question, do these two things match? So we'll run that and it prints same 3. Okay? Let me do this then. And change this to double equals other A. It's going to print out same 4 or not?
Same 4.
It's not going to print. How many votes for it's not going to print same 4? How many votes for it's going to print same 4? Why do you think it's going to print same 4?
Well, Well, it's comparing strings, isn't it?
Well, that's double equals, which is identical.
Yeah, but the strings are special in some way, aren't they?
Well, let's just find out.
Yeah,
I don't know.
Well, let's just do it slightly differently then. So there's specifically using new for the thing. And so now I'm saying that thing should have a totally different memory address. Is it going to print out same 5 or not?
What do they have same memory address on string over 8? String
So this one here is the exception. Because in this case, it said that these two guys were the same, but if I use new with double equals, it says they're different. Okay, how about this? I'm going to take A plus equals another A and other A. I'll make it a B just so that we can see. There's a B on that one, and AA plus equals a B. So originally, way back when, we had other A and other B being the same because they printed out same 3. Right? So there's the code there. And it printed out same 3 because it said those were identical. It also printed out same 4, said they're still identical. What happens if I do that? Still the same or not? There's double equals.
and 6.
They're originally the same. Are they still the same? I added the same character to each one of them. Apparently not, because it didn't print out same 6. So we've still got that little exception sitting there, right there. That's the one that they say they're identical. In these other cases, they say not identical. So there's somehow an exception to the rule.
But what makes it identical is actually the right side. Like they both are AA.
Yes. So let's talk about what's happening here and see if we can clear up the weirdity. Java was originally designed for embedded systems, as in toasters, way back when, 20 years ago, when memory was in short supply and was expensive. And so because of that, the designers of the language said that if you go and you look at code, in a lot of cases the thing that makes code bigger is all of the strings that are usually left in things, particularly for messages to human beings. Okay, so error messages and print stuff and all of that. So what they did in the language is they said, anytime we see two strings that are identical at compile time, we'll allow the compiler to let those things inhabit the same memory address. And not only that, we'll make it so that strings are immutable, so that they don't change. Okay, and so because of that, these things actually inhabit the same memory address at compile time. Now the other weirdity, because of that, because strings are unchangeable, is that anytime you do a concatenation, what this is really doing is this is taking the existing A, copying it into a new variable, concatenating the B, and then putting that back into the A reference. Okay? And so this ID number will change because it goes into, as soon as you change it, you actually get a brand new fresh copy of the thing with the new stuff added on, and the old copy sits there as being unchangeable, never to be used again. Okay? And that's the way they get around the let's merge strings together. So the rule then becomes, anytime you have two strings that the compiler can see at compile time are the same, they're going to be identical because they truly do inhabit the same memory address. But anytime you turn around at runtime and change them, or you compose strings at runtime by making them piece by piece, or concatenate strings together, then they're not identical because they never share the same memory address. They'll be totally different strings. Okay? And so the bottom line of the whole discussion is that double equals for strings 95% of the time does what you expect, and 5% of the time it does something which seems totally weird. But if you use dot equals for strings all the time, then dot equals always does a character by character by character comparison, regardless of whether or not they're in memory at the same place or not, and 100% of the time you get what you expect. Okay? And so that explains why all along I've been saying anytime we're doing string comparisons, use dot equals because it will work for you. Double equals has some weird cases where occasionally it will give you an answer that you don't expect, depending on whether you composed it at runtime or compiled it at compile time. And rather than worry about that, just always write dot equals and it always works. Okay, so that was the run through of identical versus looks like for equals. Any other questions?
Just sort of a technical note on this question on this one, but is the reason it checks the ID number because the double equals is designed for dealing with integers primarily?
The question was, is double equals designed for dealing with integers? Double equals is designed for, yeah, essentially just doing any kind of integer comparison, but objects have an ID which is an integer, so that's why double equals works for them, because the ID number is the integer. And that's why when we've had this discussion about the value that's in that thing and putting it onto lists, I've always said think of it as a phone number, because it really is truly just an integer that you're playing with. And so when we copy something onto a list, we're really just transferring the phone number into an address book. We're just playing with the number of where to find something. The thing hasn't actually been copied at all. It's still exactly where it used to be. And that's really efficient because you don't want to deal with the things. You're just interested in where they inhabit memory. It's the same thing you do in real life. And with that, we're out of here.